Good morning, everyone. Got a full room. This is great. I love this. My name is Milan Thompson-Bukovic. I'm a director in Amazon Web Services. I'm here with Andrew Goldman, VP of Product Engineering for Fluid Inc., and Andrew Kerr, who's a principal engineer with Fluid Inc. And we're here to talk to you about how to scale your applications work in the cloud using Amazon Simple Workflow. How many people went to the keynote this morning? It's great. It's a fun keynote. How many people heard or saw the video presentation that the NASA folks did? All right. How many people have heard about Simple Workflow before the keynote? All right. I love this. How many people have tried Simple Workflow? OK. So fewer people have tried. Some folks have, which is great to see. What we're going to talk about in this presentation is the type of work that Amazon Simple Workflow is useful for helping you build applications that scale in the cloud, the type of applications that our customers do today. We have a customer on stage with us, Fluid, who will talk about their experiences with Amazon Simple Workflow, and we'll help you get started with this new service introduced in February 2012. Let's start first by talking about the work. So applications do a lot of different types of work. I have a subset of all the different types of work your application could do. Obviously, it's a very small subset. But these are common types of jobs or work that's done in the cloud today by our customers. They range from scheduled processes, like taking a backup at a specific point in time, to fulfillment of orders through retail systems, to the type of media or data processing that you heard about with the NASA video this morning in the keynote, and you'll hear about later with Fluid, to infrastructure provisioning. One thing that a lot of folks don't know about Amazon Simple Workflow is that Amazon, the company, has been using and building workflow services for years now. And the reason why we've been building it is because when we build Amazon services, I'm talking Amazon.com services, I'm talking Kindle, I'm talking Amazon Web Services, we need the type of help that Simple Workflow gives to any application. We need to coordinate work. And one example of this is infrastructure provisioning. We have an application internal to Amazon that uses Amazon Simple Workflow to lay down the OS and all the required software onto a new Amazon server before it joins the Amazon fleet. And that is the entire Amazon fleet. So every single server that's put out there for any Amazon property is provisioned in a workflow using Amazon Simple Workflow. So when we talk about work, we're really talking about the type of work that you and your applications do, as well as the applications that we build within Amazon and what we do. And as I said, while Amazon Simple Workflow was launched in February 2012, earlier this year, it's really been used for a number of years, over 5, internal to Amazon to do the same sorts of things that we let our customers do today on AWS. What's very interesting about what Amazon Simple Workflow does is it helps you coordinate that work across network boundaries. And what's very interesting about the service is that it allows you to run your application in your on-premise data center or AWS or a combination of the two. And we'll talk about both situations today. Fluid will talk about how they're using Amazon Simple Workflow to coordinate work within an AWS-only environment. And when NASA goes to a deep drill down into their application at 4:30 later on today, they'll talk about how those images are coming down from the Mars Curiosity project into the AWS data center for processing and back over to their corporate data centers to be loaded up onto their website. And all of that work is coordinated by Amazon Simple Workflow. So the key thing to think about when you think about Amazon Simple Workflow is the work is there. You guys know what the work is. It's in your applications. We're not trying to change the work. What we're trying to do with Simple Workflow is coordinate that work across different data centers if you need it, across multiple machines so you get the scale of concurrency, and allow you to be able to manage long-running processes as well as short-running processes. So we have plenty of customers who run workflows that take a minute or less. We have a lot of other customers who have workflows that run for hours. And it's hard and it's complex to write the code that tracks centrally the state of those workflows that are running across multiple machines, across lots of time. That's what Simple Workflow gives you. And it also gives you the ability to control how you want your workflow to be orchestrated by events. And those events can be triggered by software. For example, your application can say, hey, I want to start my workflow now. Or it can be triggered by people. And by people, I mean somebody clicking a button on your website. We have a customer right now who puts the entire registration process into a workflow. And that registration process is kicked off by what we call human action of a user clicking a button, create an account. So let's talk about some characteristics about an application that Simple Workflow might be especially useful for. The key thing that I think our developers think about is, does your application have different paths or branches of logic? And I'll give you an example. If you have that scheduled process, I said before, a backup. If that backup succeeds, your application might want to do a set of things. It might want to take the successful snapshot and move it onto another machine. If your application fails, your backup fails, what your application might want to do is send an email to your application operators. It might want to retry that particular job 2 or 3 times and then give up. It might go through a series of branches and logic that you want to do as a response to the success or failure of your application. And what a Simple Workflow lets you do is coordinate all those different branches of logic, whether it's reacting to failure conditions quickly, or if it's reacting to success conditions and moving on to a next step in your process. I think what is really interesting about Simple Workflow is that most of our customers get excited about workflow because it helps them do concurrent work. It helps them take a process that they want to execute and manage it across many different machines. And what they find when they come to the service and they get that concurrency and they get that improved latency and scale is that Simple Workflow gives you more than that. It lets you track the history of what work happened. So you have the ability to not just track the state of the work that's being done across multiple machines, but you can also audit and find out details about failure and success conditions, as well as this ability to automatically control or orchestrate all those logical paths that I talked about. What that ends up meaning is that many different applications right now are coordinated, or a workflow can be coordinated in a workflow. And I list a bunch of different types of applications. What's interesting is that many of these types of applications are actually are in use in Amazon, the company today, being coordinated by Simple Workflow, as well as by our AWS customer base. In all of these application types, the premise of Amazon Simple Workflow is basically the same. You have a few central components or concepts that I wanted to go over. One of them is the fact that we require that when you are developing your application, you decouple the work from the logic or the coordination of that work. So as you can see in my example, let's just go back to my backup example. I have a workflow worker. It's my hamster driving the car. The workflow worker is going to actually have all the logic around what to do for the backup. It's going to have how the backup should respond to both success conditions as well as failure conditions. And all of that orchestration or that sequencing logic is really going to live within that one workflow worker. And what the workflow worker is going to do is say, I'm going to go and I need to go start some work. It's going to tell Amazon Simple Workflow. Amazon Simple Workflow is going to it keeps a task list for the work that needs to get done for that application. Amazon Simple Workflow is going to assign the work to my activity worker. Let's say that the need for work goes up. At that point, the application will add some more resources, and Amazon Simple Workflow will assign the additional work to those new resources, and now you're into heavy lifting for this particular work. Now what the workflow worker can do at that point is say, okay, once that work is done, let's say the backup has been taken, there can be another type of work. And that other type of work can be taking that backup and saving it on to a remote server. It can be logging. It can be anything you want. The key thing to note is that it's another type of work that's being coordinated by Amazon Simple Workflow in that same task list. You can have as many different types of work as you want. So after you get done with your archival of the successful backup, you can take the logging information for all of the backup information that you've done across your fleet for that day and write a report. These are all just types of work that are associated, that are in your application, coordinated by Amazon Simple Workflow and managed centrally in that task list. Again, the workflow worker is part of your application. We call it a decider in Amazon Simple Workflow terms. And it is going to have the logic for the sequencing, the failure handling, and all the different orchestration that you want Amazon Simple Workflow to do for your application. What's also important about Amazon Simple Workflow is this idea about going across different networks. Fluid will talk to you about how Amazon Simple Workflow, which is an AWS service, coordinates an AWS-only environment. But you can also coordinate work wholly within your corporate data center. So this is, we have a lot of customers who like to try things. They take one application out of a portfolio of a dozen, and they try a new technology within AWS. In this case, what you could do is you could take something that's currently in your corporate data center and try orchestrating the work using Amazon Simple Workflow. You could do the same thing if you already have your application running in AWS. Or you can try to do a more complex coordination across both the corporate data center as well as the AWS cloud, like NASA JPL did. So the key thing that we think of when we think about Amazon Simple Workflow is that we want to build a service that gives you freedom. And I've touched on this a little bit. The key thing for us is that we want you to be able to have your application service be running in wherever you want it to run. It can run in AWS, it can run it in another cloud, it can run it in your corporate data center. As long as it's being orchestrated by AWS, you can be location independent. We want you to be able to build your workflow-aware application in any programming language that you want. Now, we have a client framework called AWS Flow Framework. It's a Java client framework that makes it easier to write that decider, that workflow logic in your application. But if you're using Python, JavaScript, .NET, name your preferred language, you can write directly to the Simple Workflow APIs and do essentially the same thing. So can I get a quick show of hands? How many people in the room are Java, right? Applications in Java. OK. How many people write their apps in Ruby? OK. And Python? OK. .NET? All right. So we have a crowd here of just about any of the major programming languages. And the key thing that we want to say is that you don't have to change what language you write your application in. You can use Amazon Simple Workflow to coordinate the work in your application regardless. So the other thing that we want to make clear is that we're not asking folks to model their application in any specific hardened way. What we're saying is we want you to decouple the work from the logic around how the work gets done. But apart from that, it's your application. So how you write your work is up to you. We're just asking you to decouple between the work and the orchestration. And beyond that, the architecture of your app is really owned by you. And you can set up whatever architecture you choose. And we'll just coordinate the work that's in that architecture. So I'd like to introduce, again, Andrew and Andrew from Fluid. And they're going to talk a little bit about how they adopted Amazon Simple Workflow for their particular application.
Thank you. So Fluid has been in business as a digital agency since 1999. Over the years, we've developed specialization in creating applications for e-commerce companies that are especially fun and intuitive to use. About 5 years ago, we realized a recurring need for visual merchandising solutions. So we created the Fluid Retail suite of software as a service products. The one we'll be focusing on today primarily is Fluid Experience, which is interactive online product visualization. We also have the Fluid Configure product, which is an online product configuration platform. Fluid's focus throughout its existence, and certainly today, has been on creating usable e-commerce solutions. We're not in the business, nor do we want to be in the business of creating technical infrastructure. When we're working with e-commerce companies, we happily partner with firms like Demandware and IBM. And we're delighted to be using the AWS suite of technologies, and specifically Simple Workflow. We'll be focusing in our talk today on the administrative tools associated with Fluid Experience. We'll take a quick look here at an example of a Fluid Experience instance. This is on the Igloo Coolers site. And this image of a cooler here is an example of a Fluid Experience component. You can see you can zoom in on it, pan around. This zoomed in view that we're looking at is actually a set of tiled images like this one. So, as we contemplate the work of the Fluid Experience admin tools, we have many customers. Each customer has many products. Many of the products have many images. We quickly have a situation where the Fluid Experience admin tools are processing many, many thousands of images, taking high-resolution source imagery and preparing them for consumption on the web, as I was just showing you. The processing of images in this way is a highly resource-intensive operation. You need a lot of processor power and a lot of memory to make that happen. Like everything in all of our businesses, it's time sensitive. Nobody wants to wait for their images to be ready. Before we started using Simple Workflow, things were slow. It takes a couple of seconds to process an image to generate either a tile or to scale an image appropriately. But as you can see with these calculations, once you get to the many, many thousands of images that we're dealing with, we have delays that were quite large. Can I see a show of hands? Have any of you become victims of your own success, where the scale of your business creates a real challenge for your operations? It's a great problem to have. It's the problem we all want to have, but it's still a challenge. We found that the tipping point for us was when our customers had to wait longer than overnight to get their images generated. People were generally tolerant of clicking the button and coming back to work the next morning and having things ready. But when the queue of images grew to the point where they were having to wait multiple days, something had to give.
Thanks, Andrew.
Sure.
So if we dial back to February of this year, we had pretty much migrated all of our technology into the AWS cloud. We were using EC2, S3, RDS, all with great success. But we still had this problem of how do we process hundreds of thousands of images efficiently. We needed a solution for our customers, and we needed something that would allow us to process all these images in a concurrent way. Now, around February of this year, we got one of those nice emails that you get from AWS every couple of weeks announcing a brand new technology. This one happened to be Simple Workflow, and it came along at a perfect time for us, just when we were trying to solve this infrastructure problem. We didn't want to have to spend months writing infrastructure. How many of you have spent ages trying to write infrastructure for your projects that you don't really want to do, right? So SWF came along at a perfect time for us. All we needed to do was figure out how to refactor our code into the concept of activity workers and workflow workers. You remember in Mayland's slides the weightlifting hamster and the hamster driving a race car. In our case, the weightlifting hamster is the activity worker that does the actual image processing. The workflow worker is the the one that just makes the decisions when it's time to scale an image, when it's time to report back to our admin server that the image has been processed. We also refactored our infrastructure into two types of servers. The admin master server, which is our customer-facing server where customers go to launch batch image processing jobs, get progress on how they're doing when they've completed, reports of how the job went, and so on. And the new type of server we created was a workflow server. The workflow server is the one that actually runs the workflows and the activities using Simple Workflow. Simple Workflow ties this all together, figuring out which component needs to do what, and it does it all for us.
Thank you. So now we've laid out the challenge that we face. We need to speed things up. We need to generate the images more quickly and in a more scalable way. On the coming slides, we'll take a look at the server and service topology for how we built up the infrastructure using AWS components, including Simple Workflow, to do that. First, on the right side of this diagram, you see the admin master server. This is an EC2 instance, an M1.extra large instance. Our customers interact with the admin master server to basically say that they want to generate their images. They're ready to create the runtime imagery. By doing that, we create workflows in Simple Workflow, which then populates the static image task list, which says which images need to be resized and by how much. Next, we have the workflow server. This is another EC2 instance, this time an M1.large. The workflow server includes the workflow worker component that you see there, the hamster in the race car, sequencing the tasks, figuring out what needs to happen when. The workflow server also includes the image processing worker, which is the activity worker, weightlifting hamster, doing the actual tasks. The image processing worker retrieves its tasks from Simple Workflow from the task list and executes them. Because our infrastructure is built on EC2 and AWS, we're able to take advantage of the auto-scaling capability offered by EC2. We have a CloudWatch. CloudWatch is the AWS monitoring system. We set up a CloudWatch alarm to monitor the size of the task list. As the task list grows, it creates an alarm which notifies auto-scaling that we need more servers to process this growing task list. So in this way, using totally standard CloudWatch and EC2 auto-scaling capabilities, we're able to build a self-scaling workflow server pool to process the jobs that we need processed.
Thanks, Andrew. So let's take a look at some of the code that we use to do our Simple Workflow implementation. Looking at this class, you can see it's just a regular Java interface. Our server code was already in Java, so it was a logical choice for us to use the AWS Flow framework. And the paradigm of programming in this framework is just normal Java. You have an interface, and you write an implementation of the interface. The only difference here is we're using annotations that are specific to the Flow framework, identifying the interface as an activity, specifying certain configuration parameters like timeouts, and the last one towards the scale method there is the exponential retry annotation, which gives you fault tolerance. It's also part of the framework. If we look at the implementation of the activity, this again is the weightlifting hamster in our code. We download an image from an S3 bucket, we process the image, and then we upload it back to S3. Now this code actually is completely unchanged from before we migrated to Simple Workflow. The only thing we had to do was cut and paste the code and stick it into an activity worker. So we were able to keep all of our image processing logic the same as it was before we moved to Simple Workflow. So now that we've got our activities identified and written, the next step is identifying what the workflow is. This is the decision-making class. Your workflow workers shouldn't be doing any actual work. They just make quick decisions. They figure out what needs to be executed, what needs to be done next. So it shouldn't do things like make calls to the database, access file systems, access things on the network, and so on. So in this case, it's just another Java interface with a flow framework annotation indicating that it's a workflow. And the execute annotation indicates that this is the entry point into our workflow. The implementation of our class is fairly simple. We have two types of activity workers in this particular workflow. The one is the image processing activity, which we just saw, that does the download from S3, processing of the image, and upload back to S3. Once that is completed, the workflow collects any error information that may have happened. And then the final activity is called the workflow completion activity. That activity doesn't actually execute in our pool of workflow servers. It executes back on the admin master server as a mechanism for notifying the admin master server when a workflow has completed and if it's completed successfully or not. The final piece of the puzzle is actually launching the workflows. In our particular example, we're doing this from our image processing job that runs on the admin master server. And the code looks almost the same as it did before we, again, moved to simple workflow. We're just calling a method to scale the image. Now, it's important to note here that we could be calling this workflow potentially thousands or hundreds of thousands of times. But we don't care when or where it gets executed or on which server. Simple workflow actually takes care of all that behind-the-scenes integration for us. So now that we've taken a look at some of the code behind our particular example, we thought we'd share a few of the lessons that we learned during our implementation and some tips that we found instructive during our implementation.
Thanks, Andrew. So the first thing that we learned fairly early in the process is that we need to look at what the activity workers are doing and make sure that the servers they're running on have the right resources so that they can perform their tasks effectively. Early in the process, we ran into some thread starvation issues when we didn't have the servers properly configured, and basically the whole thing just grinds to a halt. So in our case, the image processing tasks we're performing need a lot of CPU and a lot of RAM. So we set them up on M1.large EC2 instances. The next thing is that the activity workers one activity worker doesn't take over one server. It's much more flexible than that. Simple workflow lets you configure the number of threads to allocate to the activity workers so that they can run multiple in parallel. Same thing with the workflow workers too. So you get to figure out how many threads you need for everything. So using the same principle where our image processing activity workers have a lot of work to do that consumes a lot of resources, we have a fairly low thread count of 5 on each workflow server. These settings in our circumstances let us maximize the productivity of each and every activity worker so that the images get processed quickly and smoothly. Of course, every activity worker's job will vary, and the resources they need will be different. So you just need to consider that and have the activity workers running on a properly configured server with the right number of threads.
Were you able to drive higher CPU per instance using activity factors? So in a lot of applications, you won't be able to fully use the CPU because there's a lot of latency or waiting for things. So you have 20–30% CPU, but you can't get any more throughput. So after you refactored, did you find you were able to drive higher CPU?
Yeah, we found that once we reduced the thread count so that they were all executing on full cylinders and using as much CPU as we could, we were getting CPU numbers closer to 80%.
So you were able to get more value per M1 instance.
Yes.
Thanks. Another important thing here that we saw in the hamster diagram previously is that you can have multiple different types of activities involved in a workflow. And for each type of activity, you can have different activity workers set up. Each activity worker can have its own configuration, run on its own instance type with its own thread count. So you can optimize each activity that participates in a workflow independently. For example, what we've been talking about with image processing with a lot of RAM and CPU has one type of configuration. If we had another activity that was related to this, that was transferring files over the network, perhaps those servers would need a lot of network bandwidth, but not a lot of processing power. So you can individually set up your activity workers according to the task they need to perform.
So the next tip we wanted to discuss was scaling on demand. EC2 autoscaling is your friend when you're using simple workflow. It's a very, very easy way to start building a fleet of servers that grows on demand. In our case, as we saw earlier in the topology diagram, we use a combination of EC2 autoscaling with a custom CloudWatch metric to figure out how much pending work there is in our system and what the backup is. So if we take a quick look at this code, this is a little job that runs every minute on our admin master server. It uses the Java SDK to the simple workflow API, asks for the number of open workflows that are currently in the system, and then it puts that number into CloudWatch as a custom metric called open workflows. So every minute we're getting a sort of a running tally, an approximation of how much work there is in the system. So at this point, we know the number of open workflows. We need to do something with that alarm and hook it up with autoscaling. So in EC2 autoscaling, there's a concept of a policy. We have two policies for our workflow servers. One of them is the policy that gets executed when we want to scale up, and the other one is when we want to scale down. So to hook up CloudWatch with autoscaling policies, we create alarms that are monitoring a specific metric in CloudWatch. In our case, it was the number of open workflows. And then we scale up when a certain thing happens. So in this case, we have an alarm that gets triggered if the number of open workflows has exceeded 500 for 2 minutes. And we scale down when the number of open workflows is 0 for about 5 minutes. So we scale up faster than we scale down with the anticipation that if there's a lot of pending work in the system, there's going to continue to be some for a while. So we want to scale up rapidly so our customers' jobs execute as quickly as possible. And then once those EC2 instances are running, they're on-demand instances, so we've already paid for them for an hour. So we don't want to scale down quite as aggressively so that we can make use of them if they're needed. The final thing I wanted to talk about was fault tolerance. As we saw earlier in the deck, our primary motivation for moving to simple workflow was to get all the good stuff to do with concurrency and running distributed applications. One of the nice things that we found was that simple workflow also offered built-in fault tolerance. How many of you spent a lot of time writing complex code to deal with failures in your code and having to retry things that fail? Yeah, we didn't have that logic in our application, unfortunately, at all. So our jobs weren't very fault tolerant. If a customer launched a job to scale 10,000 images and the last image failed to scale, our job would fail and it wasn't pretty for our customers. So now, with the simple addition of the exponential retry annotation that's part of the flow framework, which we add to our image processing activity, we get built-in retries. In our case, we retry up to 5 times to process the image, backing off with an exponential time. And this is great because things do occasionally go wrong during the scaling of an image. There could be a network hiccup where you couldn't get the image from S3. Now with this retry, we don't see those faults anymore, and our customers' jobs complete successfully a lot more often.
Thank you.
Oops. So we have a similar service that does conversions where we rely on external services, and sometimes they fail for no reason, and sometimes they fail with an exception. How do you figure out exceptions and logging and this kind of stuff? Do you have to homegrow it, or is it built into the system?
No, there is exception processing built into the workflow worker. So there is a try-catch finally construct within the flow framework that works just like a regular try-catch finally, except it's distributed. So you can catch exceptions, and you do get a nice stack trace and everything, and you can report that back. With the retry construct, it'll retry it 5 times, and if it keeps failing, in our case it was 5 times, and if it finally does fail after that number of times, you'll get the error report back, which you can report back to the user if you want.
So after going through this exercise, refactoring our code to use simple workflow, we ended up really achieving our goals for the speed we were looking for. One of our clients is Roots, an apparel company in Canada. A typical job for the Roots system includes about 37,000 images. We saw about a 70% performance improvement in the execution of one of their jobs. Another client of ours is Life is Good. It takes about 10% of the time that it used to take to process their 18,000 images. Perhaps more important than the speed benefits we've realized is the scale. By spreading the processing of these images over multiple servers and increasing the number of servers when the load is high, we're able to just go faster, do more work when the load is higher. So those 2 main things were the things we were hoping to accomplish, which worked great. As Andrew mentioned, fault tolerance was a sort of side benefit of the work that we've done, which has improved the usability of our system dramatically. Another advantage that we realized was decoupling of our code. Within the simple workflow framework, we have workflow workers, the hamster in the car, figuring out what needs to happen when, and then we have the activity workers processing the images separately. By dividing these things into very clearly separated components, the code in each of them becomes simpler, more focused, easier to write, and easier to maintain.
So that's an arbitrary or savings of time, right? You could always spawn more servers, more workers, and move faster if you wished, right?
Well, that's a great point. That's a great point. And yeah, I mean, that's really kind of the fun place we're at now with this system. It's set up to where it's incredibly easy to tweak the logic in auto-scaling to be more aggressive, like you suggest, to further increase performance. And then it becomes a question of, if you get too aggressive with that, you create too many servers, you increase your costs, perhaps without dramatically increasing the speed. We were just talking this morning about making that logic in there a bit more sophisticated so that we hopefully wouldn't increase our charges too much, but we would be able to hopefully increase these numbers by quite a bit. It's a great point. It's kind of a fun place to be at as a developer now, where without really making any significant code changes and without really incurring much risk, we can start tuning the system in potentially some pretty dramatic ways. So now that we've successfully optimized the image processing of Fluid Experience, we're starting to look at some other uses of simple workflow service. And 2 of those are in the Fluid Configure product that I mentioned earlier. We're looking now at the North Face's implementation of Fluid Configure. There's a custom Denali jacket configurator. On the page we're looking at here, metrics from social media are an important component of filtering and ranking these recipes, basically these custom designs, user-generated content. The number of user-generated designs can grow incredibly quickly, and maintaining accurate social media statistics across this vast pool of designs is a daunting task one that's made, or will hopefully be made, dramatically easier using simple workflow service. Another area we're looking at optimizing in Fluid Configure is the generation of the imagery. You can see here the product imagery is composed of component images that we see below. You can see as I roll over the swatches how the imagery updates, and it's basically using this component image from below. The component imagery is built using a 3D rendering engine generated from a 3D model, and we're looking right now at creating a 3D render farm in EC2 driven by simple workflow service to scale on demand like we've been talking about. I'm sorry.
So you just render your texture maps onto your rendering engine? How you guys work that?
Well, we're using the Reality Server rendering engine, which has an HTTP-based interface. So we'll set up activity workers running Reality Server, which would be in cooperating with simple workflow to get their tasks, and then the rendering would happen using using Reality Server's APIs. I mean, there's all different ways you could build it. But
is Reality Servers on a GPU based?
it is, yep. Yep. So we've had a lot of fun and seen a lot of success in using simple workflow to speed up our systems, make them more scalable, more fault tolerant, more cleanly architected. Be happy to talk with people in more detail at the conclusion of the talk if anybody has any other questions for us. Thank you.
Thank you, Andrew and Andrew. As Andy said in the keynote this morning, this conference is really about the customers. It's about you. And one of the things that we're trying to do in a lot of these sessions is bring customers like Fluid, Andrew and Andrew, forward to share their experiences of how they use services like Simple Workflow. If you want to learn more, there's a couple of sessions that I'd recommend that you hit. One of them is given by Rick Sears, who's the development leader for Amazon Simple Workflow, and he's going to talk in great detail about how to actually build applications that distribute work in the cloud using Simple Workflow. So he's going to go and take what you've learned here to the next level of really just digging in and saying, how do you go build those workflow workers, the hamster driving the car? How do you go make sure, what do the tasks do in this distributed topologies that we can open up with Amazon Simple Workflow? The other session that you might find interesting is when NASA drills down into their overall system. And they use many different parts of the AWS cloud, but they are heavy users of Amazon Simple Workflow and have been since actually before we were publicly available. And they are distributing all of their images. They're channeling all their images from the Curiosity rover all the way up to the NASA website, running through different data centers on-premise as well as AWS. If you want to drill down into that, check out their talk. We also will have usually at least one workflow person at the AWS Application Services booth, so feel free to grab somebody in that area as well. If you don't have time, there's a lot going on. I have to say I was looking at all the sessions and I was torn myself, picking which one to go to. You can explore this on your own. And we have a tab in the AWS Management Console. We have the service overview. The customer forum, as all AWS customer forums, is manned by the product team, the development team. So the same people that you're meeting here are the people who are looking at your questions in the customer forum. So if you go and you want to post a follow-up question, we'll be there to answer it for you. As a starting point, I'd really encourage folks to check out this AWS Flow Framework programming recipes. Again, even if you are not using Java, now AWS Flow Framework is a Java client framework, but even if you are not using Java, the Flow Framework programming recipes are basically samples that you can use to see how you can take the do-while loops and all the control flow you have in your existing application and turn it into a workflow worker. We've put together, I believe there's 18 code samples in this programming recipes cookbook that we've created. They're all Java, but again, if you know a little bit of Java, you can extrapolate for your other languages. And if you are using Java and you want to use the AWS Flow framework, it's a very easy way to kickstart getting your decider, or your orchestration logic into your current application. So I wanted to thank everyone for coming to this session, first one of the day. I wanted to thank again Andrew Kerr and Andrew Goldman from Fluid. And we have time at the end of this session. If you have questions, we had a bunch of questions that occurred during the talk. And if you have other questions, we will be over here in front of the stage. And we'll be here for the next 10 minutes or so. So feel free to come up after and grab us. And don't forget to fill out an evaluation form. We're eager to hear your feedback. Yeah, I believe they are. The question was, are the presentations going to be made public? I believe they are. Thank you, everyone.
Good job.
Nice work. Nicely done.
Yeah. Let's see if we're off. Are we off? Are we muted?
Are we
We're
off?
muted. Hi.